Today's lesson is 6.4, Use inscribed angles and polygons. An inscribed angle, this is an angle that starts at one point on the circle, right here at point A, and is created by the two chords, AB and AC. So this angle right here, which we would call BAC, would be considered my inscribed angle. It also creates what is called an intercepted arc. This is an arc that is created by an inscribed angle and its chords. So this would be my inscribed arc right here. Let's go ahead and mark that. There we go. There would be my intercepted arc. We're going to talk about inscribed polygons today. An inscribed polygon is a polygon that is inside a circle. This polygon happens to be a quadrilateral because it has 4 sides. And all of the corners of my inscribed polygon need to be touching the circle. They need to touch the circle. The circle is said to be a circumscribed circle because it is surrounding the polygon, touching all of its corners. All right, we have 4 theorems that we're going to talk about today, and we're going to see an example for each one. So here is our first theorem. This theorem is the measure of an inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So the measure of the inscribed angle is half the measure of the intercepted arc. So my intercepted arc for this one would be right here, and so it would be half of AB, the arc. Okay. Likewise, that would be to find this inscribed angle. Likewise, I can think of the arc is 2 times the inscribed angle. So it just depends on which one you know. So let's just think about it this way. If I know that this is 10, then I know this arc is 20. If I know the arc is 20, then I know the angle is 10. Okay, that's basically what they're saying. Let's go ahead and take a look at an example. Example 1, find the values of the inscribed angles and intercepted arcs. And here's a hint. TR is the diameter. So even though it doesn't look like it, and it doesn't necessarily have to, TR is my diameter. So I'm going to go ahead and help myself out by putting my center right here. Now let's go ahead and take a look at what they want me to find. They want me to find the measure of angle RTS. So I'm going to go from letter R to letter T to letter S. R to T to S. We want to find this angle right here. Well, we're going to use this theorem that says, since I know the arc, then it's going to just be half. It's just going to be half. So it's equal to half of arc RS. Well, that's half times 48. You remember, you can think of half, multiplying by half, is the same as dividing by 2. So we're just taking 48 and we're dividing it by 2. 24 degrees would be my answer. Now let's go ahead and let's find QT. Okay, well, we first found this one. Now let's go ahead and let's find arc QT, this one right here. We're going to use the same theorem again, which says that this is half of that. So if this is the half, then to find the arc, I'm just going to say that it's 2 times angle QRT, or it's 2 times 50, 100 degrees. Now for QR. So let me grab this. QR would be right here. There's QR. Remember in the hint, they told me that this is a diameter. If this is a diameter, it's going to take my circle and cut it into half, where this is 180 degrees and that is 180 degrees. There we go. So this together is 180 degrees. I already know that I have 100 right here. So all I have to do to find QR is take the 180 From R to T, R to Q to T, subtract the 100 in the peach, and there's QR, 80 degrees. There we go. All right, let's take a look at our next theorem. If two inscribed angles of an arc intercept the same arc, then the angles are congruent. Excuse me. Let's take a look at our two angles. So let's take a look at angle ABD. I'm going to trace it from A to D to B. A to D to B, there we go. And then I have to find my second arc. Notice that it is intercepting this arc. Here's my intercepted arc for that angle, ADB, right? This angle right here. Well, here's my other angle. Let's go ahead and make its arcs. So let's make its chords. There we go. Notice it is also intercepting this arc A to B. Let's go ahead and name that arc, that angle. It would be ACB. These two angles have to be the same because, as you can see, they are intercepting the same arc. All right, let's look at example 2. So notice that I see that same crisscross pattern that I saw in the theorem, right? There's my crisscross pattern. I see it right here. I've just got to figure out where my two angles are, So let's take a look. Here is the first angle, which they are calling X, and it's intercepting SR. And then here is my second angle, which I know is 31, and it is also intercepting SR. Both of those angles have to be 31 degrees, and so to find SR, all I have to do is 2 times 31, 62 degrees. Because whenever I know the inside, I multiply by 2, and whenever I know the outside, I divide by 2. That's how it works, okay? And to find the measure of STR, let's see, STR, that would be my peach one. Well, it's the same as the orange one, 31 degrees, right? Because they're exactly the same, because they intercept arc SR. All right, the last two theorems that we're going to talk about today are theorems about triangles and polygons inside circles. So if you have a right triangle and it is inscribed inside a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then my triangle has to be a right triangle, and the angle opposite the diameter is a right angle. So take a look at my picture here. The measure of angle ABC is 90 degrees if and only if AC is the diameter of my circle. Okay, only if AC is my diameter do I end up having a right triangle. So basically what this one is letting me know is that my hypotenuse is a diameter if I have a right triangle. Okay? A quadrilateral. Remember, a quadrilateral means that we have 4 sides. Quadrilateral is any 4-sided polygon. Can be inscribed in a circle if and only if its all opposite angles are supplementary. There's a word we haven't seen in a long time. Remember, supplementary means that we add to 180 degrees. So take a look at my quadrilateral here. D, E, F, and G do lie on circle C if and only if, here we go, D and F, D plus F is the same as E plus G, and they all equal 180 degrees. They have to equal 180. So let me go ahead and put the 180 here in the middle. And take a look. It's got to be the opposite. So these two add to 180 and those two add to 180. They have to go opposite each other inside. All right, let's take a look at our last and final example. I want you to find A and B. So if you look at our circle, we have our quadrilateral inside our circle, and it says that our theorem says that opposite sides have to add up to 180 degrees. So this one plus this one have to equal 180. So 2A plus 2A equals 180 degrees. Okay, it also says that this one plus this one is 180 degrees. So 2B plus 4B equals 180 degrees. I just have to go ahead and solve both of these equations, and then I will have A and B. So 2A plus 2A is 4A equals 180. I'm going to divide 180 by 4. A equals 45. There we go. And here I'm going to go ahead and add 2B plus 2B, that's 6B. I'm going to go ahead and divide by 6. B equals 30.